Hello everyone, I'm Pei Zhang from Red Hat. Xiang Zhenfu and I will prepare this video together. We will share the fraud detection using confidential containers on BM TDX with OpenShift AI using ITA and Trustee operator. The demo we will talk about using the ITA and Trustee to decrypt an encrypted AI model which runs in the confidential containers using TDX. A simple introduction about the fraud detection. The fraud detection is an AI model. It analyzes the credit card transactions data, including the geography, distances, the price, whether the user completed the transaction by using the hardware chip or entered a PIN number or an offline purchase. By analyzing such data, it will tell the users whether a credit card transaction for fraud or not. For more information, you can click this workshop for the details. This picture shows the three phases of the OpenShift AI when deploys fraud detection. The first phase is develop and train the AI model in the Jupyter notebook. The second phase is after the AI model is trained ready, the AI model is uploaded to the MinIO storage, and the third phase is download the AI model from the storage and run this model. So with confidential containers enabled, the main difference is that the AI model is encrypted. In the first phase, after the AI model is developed and trained ready, we encrypt this AI model, and then we upload this encrypted AI model to the storage. So when the model serving, it downloads the encrypted AI model from the storage, and then it decrypts the encrypted AI model using the decryption key. So this decryption key is from the trustee secrets, and after it gets the attestation token. So in the next slide, we will show a detailed workflow about this. After the AI model is decrypted successfully, then we will be able to run the model. So in today's demo, we will mainly focus on the third phase. This means that the model serving pod is running in the confidential containers over the confidential VM. So the general environment is that we are using the TDX experimental, and we deploy the OpenShift with confidential containers support on the TDX experimental. Okay, so this picture will show the workflow. I would give a simple introduction about each components. We can say is OpenShift on the TDX experimental. This is a confidential VM, and this is a model serving pod, like I mentioned, where this demo will mainly focus on the third phase, which is a model serving pod. It's running inside the confidential containers. There are 3 containers in this pod, and the storage initializer is responsible for download the encrypted AI model and decrypt the AI model. So we will talk about this container later. The attestation agent is running inside the TEE, and it connects to the KBS in order to perform the attestation. And the attestation agent is responsible for sending the evidence of the TEE to prove the trustworthiness of the environment. Confidential Data Hub, it facilitates the secure key retrieval for the Kata agent and applications. The KBS is a server that facilitates the remote attestation and secret delivery. The ITA, it verifies the evidence and sends the attestation token to the KBS. Okay, so now let's get back to the storage initializer in the fraud predictor pod. it downloads the encrypted AI model from the storage, and next it needs to get an decryption key. So it sends a request to the this key is from the KBS secret, and the container it requests the key through the CDH REST API, and the CDH send the request to the KBS. However, the KBS will release the key to the CDH only after it gets the attestation token. So the next step is that the attestation agent it sends the evidence from this TE to the trustee KBS, and the KBS then sends the attestation request with the evidence to the ITA. The ITA verifies the evidence, and after the verification, it sends the attestation token to the KBS. Now the KBS gets the attestation token, and it will release the key to the CDH. So the container can get this key. After the decryption key is retrieved successfully, the encrypted AI model can be decrypted successfully. So the model serving process will be continued, and the model serving containers will be running. So this is with TDX. How about without TDX? Actually, within this demo, the fraud predictor pod is default running with the RunC runtime class. The components are similar. The difference is that you can see there's no VM because it's using the RunC runtime class. So the storage initializer it downloads an encrypted AI model. Now it needs an decryption key. It sends requests to the CDH. However, it will fail this because the CDH is running inside the VM, and so the CDH is not accessible. So it fails to get the key. So this means that the encrypted AI model cannot be decrypted. So the model server process will stop. So this means that the encrypted AI model cannot be served in a non-TDX environment. Okay, so this is the slide part. Next, let's go to the demo part. Let's open the OpenShift web console. I will show the operators we have installed. It includes the Red Hat OpenShift AI, OpenShift Sandbox Containers operator, Red Hat OpenShift Serverless operator, Red Hat OpenShift Service Mesh operator, Trustee operator. So after the operators installed, then we can open the OpenShift AI from here. In the OpenShift AI web page, let's create a data science project first. Let's call it as fraud detection. So let's create it. It will create a new namespace. In this page, first let's create the storage. We will use the terminal to create the storage. Yes, now what we are doing is that we create a persistent volume, and we also create the min IO storage, local storage. Let's also set the permission of the persistent volume. Sorry. Yeah, I would give a simple introduction about the PV here. Let me check the PV. What's the PV3 shows? The PV3 is you can say it's local. It's using the local host path for the persistent volume. This persistent volume will be used by the min IO storage, as this is a demo, so we are generally we are simply using the localhost path. Okay, this YAML it's from the workshop of the from the workshop. You can see that it's mainly including the S3 setup, so you can review it. Okay, now we have created the storage. Let's get back to the pod. Get to the pods under the fraud detection project. You can see that the main IO pod is running, and also in the OpenShift AI page, you can in the data connection part you can see we created my storage. So this is the main IO storage. Compared to the demo part, this is this part, the main IO, the storage. The AI model will be uploaded to this storage. After the storage is created successfully, now we can create a workbench. The workbench is an isolated area where users can develop and train the AI model. So let's call it the fraud detection. The workbench name is fraud detection. The notebook image is TensorFlow, and let's keep it default. And the cluster storage, we need to create a new persistent storage. So this storage will be used for the Jupyter environment. As I mentioned, the workbench is an area where users can develop and train the AI model. So the related data will be so the data which used in the workbench will be saved in this storage. So we need to create a PV here for the local storage. We need to let's switch to the terminal part. Let's create the second PV. Let's call let's run this command, and I will also show the PV4. You can see it's another host path for the persistent volume, and also set the permission, read write execute permission to this part. Okay, sorry, the workbench is not created, so let's just create the workbench, and it will connect it to this persistent volume. Now let's set the permission. Let's get back to the pods. You can see that we have the second pod, the fraud detection, is running. So this fraud detection pod is compared to the three phases is this is the first phase. So the AI model will be trained, will be developed and trained inside this pod. Let's get back to the OpenShift AI. Let's open the Jupyter environment. The Jupyter environment is loading now. It's downloading. Okay, so this is the Jupyter lab. This is in this Jupyter environment, we will develop and train the AI model. So let's copy the fraud detection repo. Sorry. Let's clone it. This repo is from Emmanuel's. He adds some confidential part. So let's open the repo. You can see there are several directories and files. So we'll start from this code. In this page, we will develop and train the AI model and also encrypt the AI model. Okay, let's run in the code. We install the Python dependencies, import the dependencies, load the data. Yes, data is loaded. Okay, next let's build the model and let's train the model. So this will take about 4 minutes. I will speed up this part. Yes, model is still training. You can see the process here. Now the AI model is training. It's still in the training process. Yeah, it's close to be ready. Yeah, the training of the model is complete. Okay, so we have trained the model ready. Next step, let's continue running. Okay, let's confirm the model file was created successfully. Yeah, you can see the models are here. Let's test the model. Accuracy. So the model was created successfully. Okay, below is an example. It checks if Sally's transaction likely to be fraudulent. The data is that the distance from last transaction is 0.3, ratio to median price is 1, not using the chip, not using the PIN number, and it's an offline order. So let's see how the AI size the transaction. It's not fraud. Okay, next up, we up to now we've been able to get the AI model. The AI model has been trained ready and saved locally. So next we are going to encrypt the AI model. We use the fancy and using this key to encrypt the AI model. The file encrypted successfully. We can see the encrypted AI model. So we will we will remove an original model and just keep one in the models fraud directory. So under the models fraud directory, you can see that we have one AI model. It's encrypted AI model. Okay, so in this page we can see that the AI model is trained ready, and we encrypted this AI model and saved it locally. So in this page code, we will save the model to the storage. To save this model so that you can use it from various locations, including the other notebooks or the model server. Let's start running it. Install the required packages, import the packages, verify the upload. Okay. Seems we hit errors when uploads AI model to the storage. So let's get back to check the data connections. We can see that seems I forgot to add the data connection to this workbench. So let's fix it. Let me edit the workbench, the fraud detection. Let's add these data connections. So we can use the existed data connections, which called my storage. So let's update this workbench. Now you can see that my storage is connected to the fraud detection workbench. Okay, so next let's try to save the model again. Yeah, let's start running here. select. Okay, upload and check again. Okay, seems it's still error. Let's start from the beginning. Yeah, import the packages, verifies uploads, and upload and check again. Yeah, great. We can see that the models has been uploaded to the storage. Yeah, the model is here. Okay, so after fixing some issues, we can see that the encrypted AI model has been uploaded to the storage. Okay, so next step, let's serve this model. Model serving, let's call it the model name as fraud. Serving runtime, let's choose OpenVINO. The model framework, let's keep the default one. The model location, we can choose the AI model from the storage. The storage is my storage, and the path is models fraud. Okay, let's deploy the AI model. Switch to the pod part, you can see that we have the third pod is running. Compared to the slide, this is the third phase, which this pod we will run it with the confidential containers, but with default one, it's using the run C runtime class. You can see that the init error, this is expected, just like I explained in the slides before. This is because it's trying to get the decryption key from the CDH. However, the CDH is not accessible, so it fails to decrypt the AI model. So that's why the storage initializer, it fails. And the storage initializer is a init container. Okay, so let's switch to the CataCC TDX. Thanks to Xiangchun's efforts, we could use these two commands to simplify the steps. This command, it updates the OpenVINO image version, which is a workable one for the bare metal, and this command is disable the ITA set car. This is because the ITA set car will crash, will fail start up, so we simply disable it as a workaround, and we also add the runtime class as CataCC TDX. Okay, let's run these two commands. Yeah, the image is patched. These two commands is patched. So let's get back to the pods. You can see we have an extra new pod is running. It's with CataCC TDX, and during this time I would switch to the KBS logs. We will say let's get back to the end of the KBS logs, and the init container during when it downloaded the encrypted AI model, it will also need to get the decryption key, and when it gets the decryption key, it will need to get this resource only after it gets the attestation token. You can see the logs has come out. You can see that the ITA Antitrust Authority, it posted the attestation request, and after the KBS gets the attestation token, you can see the resource access request passes the policy check. So the get resource from the KBS default key login is successfully. So this means that the init container can get this decryption key successfully. Yeah. it's still the pod initializing. This is expected. This is because the the VM size is large. We set 22 vCPUs and 120 GB memories because the total size of the images inside the pod is about 7 GB, so it's large. So that's why we set a large VM, and the pod will take a bit while. Okay, let's see the logs of the storage initializer. You can see there are 3 containers and the storage initializer. Let's check the logs. You can see in these logs that first it copied the encrypted AI module from the S3 storage, and then it retrieves the decryption key from the KBS, and after gets the decryption key, it will decrypt the encrypted AI module, and the file decrypted successfully. So yeah, so this means that the AI model is decrypted successfully, and it can be, this AI model will be served in the other 2 containers. Yeah. Now these 2 containers is running. Let's get back to the pod page. Here you can see that the fraud predictor 02 is running. So this means that the this pod is running with the kata cc TDX. We can confirm it by checking the YAML file. Let's check the runtime class name. Yeah, the runtime class name is kata cc TDX. So this means that the model has been served successfully, and we can get this inference endpoint. So let's copy it and test it. Let's copy this link and open the Jupyter environment. Let's open this page. This page is the deployed model name is fraud, and the inference endpoint. Let's copy the one of the model serving we deployed, and let's run this. Okay, this is the request function. Build and submit the REST request. Okay, so this is a fraud. Okay, the next is 2 examples. The first example is that the user buys a coffee. In this example, the user is buying a coffee. The parameters are same location as the last transaction. Distance is 0. Same median price 1. The data is 1. User is using the PIN number and is using the chip, and it's an offline transaction. So let's say how the AI predicts this. Here the AI model thinks this is not a fraud. The second example is that someone stole the user's credit card and buying something online. The parameters are this very far away from the last transaction. The distance is 100. Similar median price data is 1.2. Not using chip, not using PIN number, and it's an online transaction. So let's see how the AI answers. It's the model thinks this is not a fraud. Okay, so these 2 examples shows that we can get the prediction of the transaction of the credit card transaction from the AI data. Yeah, that's all the demos we would like to show. Thank you for your watching.